Hello my lovely viewers and my dear students. This is Miss Ruchika welcoming you to today's session for grade 9 and 10 students, and in this session today we are going to be covering part 2 of our new series on probability and measurement that we started with, and the topic for today is tree diagrams on probability or the probability tree diagrams. So let's get started. Today's video is going to be part 2 of the chapter probability and measurement that we started a few days back, and this is going to be a useful session for all my grade 9 and my grade 10 students. So let me tell you now the learning objectives of this session. In the session today on probability tree diagrams, you're first going to recall the 3 different ways in which you can represent or write a sample space, and then you will be solving questions on the probability tree diagrams. You will also learn in the session how to draw these diagrams and use them for solving questions. Okay, let's solve one example, and this will help you to recall the last session. In this question, you have the experiment that the coin is tossed, and after that a number cube is rolled. You have to represent, or you have to write the sample space for this experiment in 3 different ways. Number 1, you have to give the organized list. Number 2, you have to do the table, and number 3, you have to do the tree diagram. So let's see what are the possible outcomes. When you toss a coin here, I have taken a dirham coin. It may be any other coin in your own currency. Then the possible outcomes or the sample space will look like this. So it will have 2 outcomes. Either the coin can land on a head or a tail. So these are the 2 possible outcomes. For the number die, for the die that you roll, there may be 6 possible outcomes, as you can see here in this diagram, that there are 6 numbers, any one of them can come on the top when you roll a die. So 1, 2, 3, 4, 5, 6, these are the 6 outcomes in this experiment. So using this information, now we are going to just write the 3 ways. Let's start with the first one, the organized list. Let's start. What we are trying to recall here are the 3 different ways of representation of sample space. You already have seen what are the possible outcomes in the experiment. So let's do the first one, which is organized list. So in the organized list, you can see that for the first experiment, when you are tossing the coin, either head can come or tail can come. And for the die, there are 6 possible. So let's just do the combination. So this one talks about when you have a head on the coin and number 1 on the die. Similarly, head number 2, head number 3, head number 4, head with number 5, head with number 6. So these are the possible outcomes that can be listed here in this form for the sample space for the first part. Now if you get tail on the coin, again you have 6 outcomes that you can write here. So with the tail you have 3, with the tail you have 4, with the tail you have 5 on the die, and tail with 6. So I think now we have covered all of the possible outcomes. So you can count them, and here you can see there are 12 outcomes that you have listed in this organized list. That was the first representation. Let's do the second one now, where you have to do the table. So table, I hope you recall from the last video, will have rows and columns. So the same answer that we have got for the first part, we are now just going to put it in a row and column format. So what I'm going to be doing here, I will draw a table. Now I'm drawing from freehand, so it will not be that neat, but you can use your scale or ruler to write your outcomes in the table. So draw a rough table here, and I'm putting head and tail, the 2 outcomes here in the first 2 rows. Let me complete the table, and here on the columns I'm putting the number which is coming on the dice. 1, 2, 3, 4, 5 and 6. So that completes the table. Now let's write the entries of the table in between. So I'll go with red again. So head with 1. So you take combination, you take the row and take the column. So that's the first entry. Head with the second number, H2, H3. So you're taking the row first and then the number from the column. This is another way, a much more organized way in which you are putting the outcomes or the sample space in the table. Now comes the second row. This row refers to tail, so I will keep tail in all of the first outcomes of the experiment, and then the numbers on the die. So 1, 2, 3, 4, 5 and 6. That completes the table, and this is how you have represented the same sample space in the tabular format in rows and columns. Okay, so let's continue the question with the last part. We are going to now conclude with the tree diagram. So for the tree diagram, again we are going to write the sample space. I'm denoting it with a capital S. So this sample space will be the list of the possible outcomes, and it will have stages. So let me write.
So there is going to be first stage and second stage for this experiment, and when we write the sample space at stage 1, we divide it into 2 parts, head and tail. For the second stage, there are going to be 6 outcomes, and each part, head or tail, is going to be divided into 6 branches for the tree diagram. As you can see, for head there are going to be 6 outcomes in the second stage: head and 1, head and 2, head and 3, head and 4, head and 5 and head and 6. Similarly, for the tails, there are going to be 6 branches for the 6 outcomes that will come in the second stage, and these outcomes can be listed as T1, T2, T3, T4, T5 and T6. So this is how the tree diagram looks like for the 2 stages for this question. So let's see now the final.
Okay, so the final solution for the question can be summarized in this way, where for the first part you have the organized list. For the second part you have the table, which is of rows and columns, and the last part is definitely your probability tree, which is divided into so many branches. So this is the summary of the whole question. Let's now dive into more detail for the main key concept for today, which is the tree diagram. So as you saw in the last slide when we did the tree diagram, it is an organized table, and it has line segments, it has branches. We are dividing the outcomes into the possible cases, and it is a tree diagram which is showing the possible experiment outcomes. So it can have many stages. In the last question it was a 2-stage tree diagram or 2-stage probability tree, where an experiment had 2 stages or 2 events. So the first stage in that example which we just finished was where you were tossing the coin. So you had head or tail, 2 options, and in the second stage of that same experiment you had 6 options where you were rolling the die. Now there can be more than 2 stages also, and in that stage it will be called a multi-stage experiment, and as the name suggests, multi means many, so it is going to have more than 2 stages. So we would like to just take some more examples now of multiple stage probability tree diagrams. So let's see and understand how we do that. Okay, so let me take example 2. This is an example of multi-stage tree diagram. I'll read the question first for you. It's like a word problem, and then you need to use this information given to draw the tree diagram. So a chef's salad at a local restaurant. We are going to highlight some important information. Comes with a choice of French, ranch, blue cheese dressing. So there are 3 options for the dressings. As you can see, we will number them 1, 2, 3. And then there are some optional toppings. Okay, so what are these optional toppings? Let's see. One is cheese, one is turkey, and one is eggs. So you can have these 3 optional toppings. What you need to do, you need to draw the tree diagram here, and then you need to represent the sample space of what possible salad orders can be there. So first of all, we will look at the number of stages that are possible. Okay, so first stage you can see you have the option of whether you want French or you want ranch or you want the blue cheese. So that is an option for the dressing. So for the dressing, we've already numbered 1, 2, 3. There are 3 options, and because just to avoid your tree diagram becoming long and messy, we are going to write just the initial. So capital F represents French, capital R represents your ranch, and BC represents your blue cheese. So these capital letters we're going to use in our tree diagram. Next, you have the options. So because these are optional, for the salad you may go for it or you may not go for it. So if you're taking cheese as the option, then it will be capital C, and if you're not taking it, then it will be NC, that is not cheese. Next option is for turkey, so capital T for turkey and capital NT for not turkey. This is the next stage. And last stage is for eggs, whether you want to have the eggs, capital E, whether you don't want to have the eggs, that is capital NE. So 1, 2, 3 and 4. These are going to be the 4 stages. That's why it is a multi-stage tree diagram. I hope that is understood how you identify the stages, and let's now see in the next slide how we draw the tree diagram. So let's now draw the tree diagram with the 4 stages. So I'm going to write a capital S to represent the sample space, and I will mark here first stage, second stage, third stage, and the last fourth stage. So let's see how we are doing. At the stage 1, you have the 3 options, 1, 2, 3, 4 stages. There are 3 options, there are 2 options, 2 options and 2 options. I'm just using this information from the previous slide to draw the tree diagrams. So let's divide into the first stage. There are 3 options, so I'm going to mark with 3 arrows, 1, 2 and 3. So let me write with a different color. The first stage will have F, R or BC, 3 options. So we are done with the first stage. Let's move to the second stage. For the second stage, each option can have 2 more options. So F can have 2 options, R can also have 2 options, C can also have 2 options. So let's write these 2 options now. So the options are either it can be cheese or no cheese. So this is how I write all the possible cases. So we are done with stage 1 and stage 2. Let's move to stage 3. For stage 3, there are again 2 options for each part. So either it can be turkey or no turkey. So I'm going to again divide each part into 2. So look carefully, you have to manage your space. So when you're drawing this tree diagram in a notebook, make sure you have appropriate spacing so that you can write all the options very, very clearly. So I have the option of taking the turkey or not taking the turkey. So each part divides into these cases. So simple way of just listing everything neatly here is what you want, so that your tree diagram looks nice and clear. We are now on the 4th stage, where you have option of either taking the eggs or not taking the eggs. We are again going to divide each part into 2. Now this can get a little messier here because there are so many options that we need to write, but be careful, have nice spacing so that you don't have the issue of mixing of the values. So I'm going to just make it here for these 2 and then smaller arrows because of less space. So I'll write X and no X, and this is the last possible option for the stage. So this is the 4th stage that now we are going to be completing. So X, no X, X, no X, X, no X, and very similarly we fill up everything which is remaining. Once you fill the 4th stage complete, I want you to reflect on the question and think about what can be the possible outcomes. So now if you are able to write your possible outcomes, let's use a different ink here now. So we are now listing all possible outcomes. So first, before we list, let me give you a shortcut to write these numbers. In first stage, if you see, there were how many options? 3. In the second stage, 2. In the third stage also 2, and in the 4th stage also 2. So a shortcut to find the number of possible outcomes would be just to multiply all of these. So the number of possible outcomes, as you would see, this is actually called as a theorem. You will see that in the next one, can be calculated by multiplying. So 3 with 2 with 2 with 2. Just multiply all of this.
So when you multiply 3 with 2 with 2 with 2, you are going to get 24 as the answer. So that means the number of possible outcomes for this tree diagram is going to be 24. And this theorem you will see later is going to be called by a theorem called as fundamental theorem of counting.
Let's summarize the solution now for the multi-stage tree diagram. You can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23 and 24. So there are number of possible outcomes, 24. So 24 possible outcomes are there for this multi-stage tree diagram. So very similar to the previous question, now I'm giving you one homework question that I want you to try, and you may check your answer in the next slide, and make sure you draw the tree diagram nicely following all the steps that were shown in the last problem. So when you solve your question, your tree diagram would come out to be in this way. You can check your solution. And that brings us to the end of today's session, where we focused on probability tree diagrams. I hope this session was useful for you. Put in your comments if you have any questions or queries, and that is all from my side. So this is Ms. Ruchika signing off for today's session. Bye students. Upcoming video alert for all my dear students. The next video for grade 9 and 10 would be on probability and measurement. That will be part 3 of the session on fundamental counting principle. So what are you waiting for? Hit that subscribe button and press that bell icon so that you receive all the notification about my videos. See you in my next video. Please watch my videos and don't forget to like, share and subscribe to my channel.